Cool. Hey everyone, my name is Jack. That's me on Twitter. I work for a company called Pusher. Adam's got the old logo on his slides, so we might have to stop sponsoring soon. But yeah, Pusher. Who's heard of Pusher out of interest, and not just from a second ago? Cool. So we're like a hosted real-time API platform. Makes it really easy to send data in real time over WebSockets. We host it all, deal with all the boring bits for you, and let you build really cool real-time apps. So feel free to come and grab me or look online to find out more about that. But yeah, I'm here today to talk about React, which hopefully you're here to listen to a talk or two on React. You picked a really good topic. Stack Overflow confirms that React is trending at 311%, whatever that means. But Hacker News is going to absolutely love you, and that's really more important than anything else. So going through this talk, I'm going to obviously talk very specifically about React, but what I really want to get across is that the ideas in React are more important than React itself. Some of the ideas it's brought to developing client-side applications in the browser, and not just in the browser, as we'll hear about later on, are way more important than the framework itself. As we know in this JavaScript age, frameworks come and go every few minutes, but I think some of the ideas that React has brought us in terms of its component architecture and its approach to rendering will probably persist long after React is replaced by the new thing, which isn't Angular 2. So even if you're not potentially going to use React today or in a project, I think some of the ideas are really interesting that we can take. Even if you're working in an Angular 1 app or an Ember app or whatever kind of app, backbone even, I think some of the ideas from React can definitely be applied to those applications. And the idea behind React, and this is actually something we see across all major frameworks these days, is this idea of a component architecture. So instead of building one big mammoth app that's really difficult to work with, really difficult to kind of make sense of, we split the app up into lots of little components. So if you think of like a Facebook type application, which is actually, by the way, powered by React, and it's where React came from, you can think of it as a series of small components. So you can break these down into lots of different levels. So at a very high level, I have my header component, I have a nav component, I have my newsfeed, and then I've got like a chat in the bottom right with Alice that's popped up. But you could go into, I could pick the chat with Alice and produce the kind of 10 smaller components that make up that chat area. And working in this way, when we have this tree of components that's being rendered, is really, really nice, because what it allows is for people to work on different bits without conflicting with others, but also for you to be able to really zoom in on the little bit of the actual application you care about. Say you're a Facebook engineer, note how many friends I have, by the way, and you have to work on a bug with the chat. You can just go straight to that component. Making sense of these applications is way easier than making sense of like some big monolith that isn't structured in this way, because every component is responsible for something, and it's very easy to track down what that component does and where it lives. So building applications in this way generally is being considered a pretty good approach. Although I just dissed it a minute ago, Angular 2 is doing this with its kind of components using the decorator syntax. Ember is kind of ditching controllers in Ember 2 in favor of a component approach. React is obviously doing it. Whatever the new framework is that just got put on Hacker News is also probably doing it. There's like Vue.js, there's a ton of them, and most frameworks are going down this component route. So even if you don't like React or you don't end up using React, I think you can hopefully still take something away from this. But I am here to talk very specifically about React, so I'm going to try and show you a bunch of code through this. I'll put the slides online once I've sat down after the talk, and all the code examples have a link to a JS bin, which will run those code demos for you, so you can go and grab them. I've also got links to like on GitHub, where I've got lots of sample repositories and so on. So if we start with the hello world of React, I'm actually going to take my hoodie off because React is pretty cool, and it's quite warm in here. So this is the hello world of React. So we call this create class, and this I would have called this create component if I was clever enough to work with Facebook. But this is creating this hello world as a React component. Note the capital H in hello world is important. React components have to be named with a capital at the beginning, and then you have to define this method called render. And this basically says like, what does this component look like when we actually put it into the DOM, into our browser? And then, given that we're in a JavaScript file, we have this HTML bang smack in the middle of it, which states what our component should do. So in this case, we return a heading one that says hello world. And this looks really weird, and this freaks a lot of people out, and it freaked me out when I first got started with React, this idea that we have HTML in our JavaScript. And of course, you need something to convert this into JavaScript, so you have to use something like Babel to transpile it. But this is called JSX. And it's HTML that will be converted to JavaScript by something, normally Babel, ahead of it being run. And this seems like a dreadful idea, but this really is actually a really nice thing. It's really nice to work with. And hopefully some of the code examples later on will demonstrate that. But the main point here is it's not HTML in your JavaScript. It's actually the kind of the wrong way to think about it. Because it's being converted, it's actually JavaScript in your JavaScript. What I mean by that, which that is a dreadful slide, but what I mean by that is if you have an input on the top, which you have some app, which you assign to be this JS X component nav, with a property color equals blue, it will get converted into the code below. So there's nothing to stop you writing React apps using the React.createElement syntax and never actually touching JSX at all. The only reason you would really use JSX is just for a bit of a nicer syntax. In my experience, I've also found it really beneficial if you're working on an application where some non-heavy JavaScript engineers, or not even engineers, have to work with the code base because they see HTML effectively, and you can kind of lie to them and tell you it's HTML. So I found that really nice, but there's no requirement to use JSX, but I will throughout all these demos. So if we have our hello world component, we have this render function that returns hello world. We use a React DOM package to render it. So we give it the component, and we tell it where to render to, which I've totally got highlighted on the next slide. So React DOM is a separate package to React, which deals purely with all the actual the nitty-gritty of rendering to the DOM. The reason this is split out is because, as we'll see with React Native, React exists in way more than one place. It's not designed purely for the browser anymore. So React is designed to be as environment agnostic as it can be, and then there's packages like React DOM that do the nitty-gritty of a particular environment. So I render the component. I could use an open tag and a closing tag, or I can use a self-closing tag, as you see here. Self-closing tags are more usually used in React land. And then if I run that, I get hello world into my browser. And those links, these should hopefully all be live links, so you can go and edit and play with these if you want. So this is kind of our very first component, but it's pretty boring. We probably want to do a little bit more with React components than this. A kind of running theme throughout this presentation is the idea that components can be reusable. That hopefully, the overall goal is if you create a component for like a drop-down in one form, you want to be able to reuse that component later on in another form. That's kind of how we work in this component-based architecture, where we want to reuse components and also layer them on top of each other. So just having a component that statically returns some text or does something is kind of boring. You'll often want to be able to configure components. So let's say you have a form drop-down in one place that needs to be, that needs to do some behavior in one place, and in another form you need it to act slightly differently. You could create two entirely separate components, but we want to reuse as much code as we can between them when they share most of the same functionality. So React allows us to pass in certain options or properties to components to allow us to configure them. So they're properties, but in kind of all the React documentation and terminology, you'll hear them referred to as props, so I'll refer to them as props throughout the presentation. So say I want to create a person component, and this will render some information about me to the screen. So here I'll return a div with a heading to with my name, and I use these curly braces to input an actual JavaScript variable, this.props.name, and my fave color. It's favorite in the example, but fave makes it fit on one line in my slides. And this will output name and favorite color. I can then pass these in, funnily enough, exactly as you would imagine, just like HTML attributes. Name is Jack and color equals blue. And then you see there, that's probably quite small, but I do get name, Jack, and favorite color blue. And it's important to note as well that these can be strings like they are here, but I could also pass in JavaScript objects, functions, numbers, etc. So I can pass anything here, because this line is actually going to be converted into JavaScript. So we can pass functions if we need to, objects, whatever. So we can use props to customize components, and that's really nice. We can make them behave in different ways. But a kind of word of warning on this, props aren't just for Christmas. Once you have a component and you allow a user to customize it via some properties, they're almost certainly going to want to customize it via that property forever. So you've got to be kind of slightly considered and a little bit careful when it comes to deciding what elements you'll allow people to customize, or what properties you'll be allowing them to pass in, because the chances are you're going to have to deal with that for the rest of the time. If you find yourself having a component with 10 different properties users can pass in, there's probably actually 2 different components or more hiding in there waiting for you to find them. So you should use props to allow certain behaviors to be tweaked, but you should be careful around considering when you should do it, and when actually you just want two entirely separate components. The key thing as well is that props is data the component doesn't change. So when a component gets given properties, like this one here, where we get the name and the color, the component isn't allowed to change properties. They're immutable as far as the component is concerned. So the component, if this component also had a form to let me change the name, I couldn't have a prop as name because I wouldn't be able to edit it. So props are immutable, they're read-only, and you can only read from them. These components are actually the best kind. In building applications, you'll have some components that need more than props, and we'll come on to that in a minute, but you should strive as much as possible for components purely with properties, because they're just going to be much easier to work with than components that deal in state and data that changes. If your component's taking in some data and it's rendering based on that data, but never manipulating it, they're way easier to work with. So you should strive for these type of components. And we'll talk more about this through the presentation. However, sometimes we do have components that need to change some data, and in React land we call this state. So I've got the kind of standard example, a button you can turn on and off. So I'm going to create a component called onOff. We have this getInitialState function. This is expected to return an object of keys and values which represents the initial state of our component. So in this component I have one property on my state called on, and it's initially set to false because this button is off by default. And in my render function, I can just use a JavaScript ternary operator. If the state is on is true, I'll output on, and if it's off, I'll output off. So by default, because the initial state returns on to be false, this will actually display toggle and then the text off just below it. If I want to change the state or allow the user to change the state, I need to listen to an event, which is that button being clicked. React packed in a whole event system that acts very much as you'd expect. If you've ever worked with JavaScript events, it will be kind of pretty straightforward. We use onClick to allow us to bind to an event on this button. And I use the curly braces again to pass in a function that will be called when the button is clicked. So in this case, I pass in this .toggle. And in this class, I define toggle as a function, and React provides the setState method, and we give this method an object with the the keys in our state and the values we want those to be set to. So in this case, I'm going to take the on key or the on value and swap it. So I'll just toggle it between true or false depending on what it was previously. It's important though that you have to use setState here. The reason behind that is when you call setState, React knows that you probably need to re-render something to the DOM. Your browser needs to be updated. By calling this .setState, you inform React that that's the case, and React will do the clever work to re-render it for you. This also means if you call setState 5 times, one after the other, really rapidly, React can kind of batch those up and not re-render 5 times, only do it once or maybe twice. And if I do that, hopefully this is a video. This is not a video. The next slide a video. One of them is. No? Yeah. It's not playing on my screen, which is particularly annoying. So I'll just trust you that I'm clicking toggle, hopefully, and it's swapping between on and off. Or you're already doing a really good ruse, and I don't know. Yeah. So that's how we deal with state. We call this .setState, that one, and we pass in the new values that we want to be set. And what I really like about React is that we didn't have to deal with how we then trigger a re-render or any of that. React packs all that in for us. And the reason React can do this, and the reason that React is so efficient at doing this, is because your render function is actually what's called a pure function. What that means is it doesn't take any external outputs. It takes the current state of the component and the properties and produces some virtual DOM, like a JavaScript representation of the DOM, that React can then take and make a reality on the page. What this means in actual kind of proper terminology is that if you call render twice with the same data, you'll always get the same output back. Only when you call it with some new data do you get a brand new virtual DOM. What's really cool about this is when you call setState or a property changes, React will call render and get the virtual DOM of the new state. It will then compare that to the real DOM in the browser and figure out the minimum kind of DOM manipulations required to make the two equal. By doing this, it makes React render really, really efficient, and that means that we just don't have to worry about that or really concern ourselves with that. Once your application grows to a certain size, you might start hitting some performance bugs, and React does have some kind of tools to let you profile them and track them down. But for the most part, I've actually never run into a problem with re-rendering being really, really expensive, which is really nice. You can kind of trust the clever bots at Facebook to make this really efficient, and we can just have a fun time. And the key thing going back to state is that it's data the component owns and will change. So in my case, the on-off component owns that bit of state that determines whether we should show on and off, and it knows how to change it. As I said, just to hammer it down, you should really use props by default and really consider when you want to use state. In React land, we would call components smart or dumb, where a dumb component doesn't have any state and a smart component does. And you should strive for as many dumb components as possible because they're easier to work with, and try and keep your state down to as few as you can. And to really kind of hammer this home, React in version 0.14 introduced what are called pure functional components, or as I just said, dumb components. If you have a component that you are sure that is never going to need any state, you can just define it as a plain old function, and React will realize what's going on there and create the component for you. So in this case, showName is a React component, but it's actually just a pure JavaScript function that can take in some properties, and then the body or this function is expected to define the render method effectively. It's just a shortcut. So if you're creating components that only have a render property and take in some properties, you can use these pure components instead. React treats them much the same as far as you're concerned. It will still render them. You can still render them in the React DOM call as you would any other component. What it means is you've avoided the kind of overhead of creating a whole full React component. And this is a couple of quotes from the release candidate when these were introduced. This pattern is designed to encourage the creation of these simple components that should comprise large portions of your apps. Although it hasn't happened yet, at least to my knowledge, maybe it has, they just haven't kind of talked about it. In the future, there's a lot of potential for React to spot these components that are never going to need state and perform a bunch of performance optimizations on them to make them even quicker as well. So you should really, you should quite aggressively kind of aim for these types of components. And what this also should encourage you to do is keep your components really, really small. Like components that have one line of HTML returned based on a property are kind of fine. You should aggressively do this. It's also way easier, in my experience, to take two really small components and merge them into one than it is to take one huge component and start twisting it up. So it's better to do it that way around. As I said, you get efficient rendering for free as well. I'll just give you an example. Say we have Facebook represented by this tree of components, and then we have this node down in the bottom left that changes. We know that only the ones below it might need to be re-rendered, not the whole thing needs to be re-rendered. And React is clever enough to figure that out for us. It will just look at that bit and knows that your kind of re-rendering is limited to that small chunk of your entire application. So React is smart enough to know not to re-render the whole thing every single time, not to even check if it needs to re-render the whole thing, and just stick to the bit that might possibly need re-rendering. And I don't really know why I've got this slide in it, but you can imagine, you know, if React thinks a bit in the top right has changed, it doesn't have to touch the rest of the page. And so as we build small components to piece up applications, we need to start putting components in components, in components in components. And this really is your whole application will end up being a big tree of these components. You'll have one component at the very top, and then you'll end up with this tree structure as you branch down. The components I've showed you so far, I've only rendered HTML into them, but you can render components within other components as well. Just give you a bit more of an example of that. Say I'm building like the new Gmail, and I've got this mailbox component which is going to represent my entire mailbox. It has some state. You might fetch this from an API, but in my case I've just hard-coded it. It's an object with the messages key, which is an array of objects representing some messages I've received. So this mailbox has some state, which is some messages, but if we put all the logic related to rendering all of these messages onto the screen and maybe clicking a button to delete the message or whatever it might be, this mailbox component is going to become very big very, very quickly. So instead we can render subcomponents that are responsible for dealing with an individual message. So inside the render function of this mailbox component, I put this here because I can't fit it all on one slide, looks something like this. So first I grab the messages off the state, and then one of the great things about working with React and JSX, where the JSX is actually JavaScript, is that we can do things like map over arrays of JavaScript objects and return JSX elements or virtual DOM nodes. So I can map over my messages, and so for every message in that array, what I'm going to get back is this JSX or this React element that represents a message. So I have this list item, then inside there I render my message component. This key property, by the way, is a property React needs, so it can map DOM elements onto particular messages in an array. So if you have an array of objects and each one is mapping to a DOM element, React needs some key to kind of link them up. So you can provide it via the special key property, which is one that React particularly looks for. What's great about this, by the way, is never do this by default, because when you need to do it, React will actually warn you in the console in development mode that you're missing a key property on a specific element. So don't, I taught a workshop a couple of months ago, and someone started adding key to every single element they ever had in the render function, which is a slight misunderstanding. My advice here is don't do it until the React console warns at you that you should do it. You'll just get a console warning in your browser. Then inside that list item, we render this message component. We say message 3 times on one line, but we create this message component and we pass in a property called message. And here, instead of passing in a string like Jack or blue for my favorite color, as we did earlier, I use curly braces to insert a JavaScript thing instead. So here, the message property of the message component will be the message variable. I'm glad that's really clear. So we have this message component which is responsible for rendering an individual message, and it has an object which is the message that it knows about. Crucially, this component doesn't know about the whole array of all the messages, just the one that it needs to worry about. So the result of mapping over that array of objects is returned to me in this mails variable, and at the bottom I just return an unordered list with those array of JSX elements in it, and React knows what to do with those and create an unordered list for me. The message component in this case happens to be really simple. We just grab the title from the message and render it inside a heading. But you can imagine in this component we'd now have the logic for clicking to archive or delete or reply or whatever it might be. But you've now got this component which only deals with one particular message and doesn't know about the whole state of the system. So you should kind of aggressively break down this big like mailbox concept into lots of smaller ones, going further and further down as you go. If you want to have a play with this, I realise that's quite a lot of code to fit onto quite small slides. That's on JSBin, and you can have a look at it. I've just got JSPM on the brain. And as well, as you're building these bigger applications, you should aim to create a bunch of components that are entirely reusable. If you've got like a team of developers working on a big application, chances are you're all going to need the similar sort of things at one point. You're definitely all going to have to build a form to hit some API, all that kind of stuff. And you shouldn't make every single developer write that stuff over and over again. I can't stand writing forms. So we can do a bunch of work to make our components more reusable. We've seen already about properties and how we define and can take in properties. But there's a few extra tips you can use to avoid yourself hating the previous 6 months as you have to debug some code you haven't seen in a while. So if I go back to my person component, I'm returning this.proptop name has a favorite color of this.props.color. I render it with Jack, and my favorite color is blue, and that works fine. However, if I say this person component is something a bit more complicated and less contrived, and later on I come back to it and I reuse it and I forget that I need to pass in a certain property, I just pass in color equals blue, that's going to be broken, has a favorite color of blue. I might even forget that it needs properties altogether, and then I'm just going to get has a favorite color of, which is no good to anyone. And I will give you that this person component is a very contrived example of a component that you'll probably never build ever. But the idea here of you kind of you almost want to be able to document what properties you need and what properties the component expects. Thankfully, React got your back with this thing called prop types. This is basically a way of your component self-documenting what properties it expects to take, what properties it might expect or might not expect, and what types they are as well. So I'm going to just alias react.proptypes this variable types, just to save some space on the screen. And then in my component, I define this prop types object. Here, every key is the name of a property this component might take, and then the value comes from the React prop types and defines its type and also if it's required. So here, name is types.string, which comes from React, and then dot is required. And that means if this component is ever rendered without that property, it will throw an error into the console. I do the same with color. I think I've got a link, or if not, if you Google React prop types, you'll find it. You can do like types.array of, and then string, and you can do all sorts here to really thoroughly document what your component can take. If you leave out is required, by the way, and then you don't pass it in, you won't get any error or warning in the console. But as a developer, I can then go and look at your code for this component and see all the prop types. So even if sometimes this doesn't lead to an error or a warning in the console, it does mean if I'm trying to use your component, I can't quite figure it out, I can pull up the code and see this prop types object which neatly documents what I can and can't pass in. So I really, really highly recommend you doing this by default. React doesn't enforce you to, but it would be kind of nice if it did, because I think this is really beneficial. Just to give you an idea of what that looks like, if I declared those prop types as required, you'll get this warning in the console, and you can see that on JSPM too. So you should absolutely do this. You should absolutely use prop types. As I said, if I had my way, React would actually warn you if you didn't define prop types on any component that you were using with properties. But unfortunately, I don't always get my own way. Importantly as well, this won't slow you down in production. Prop types are never checked in production. It's only used in the dev build. There are effectively two builds of React available to you. There's the developer build and the production build. Developer build has a bunch of extra check, like prop types, that the production build won't. So you don't have to worry about these type checks running in production and slowing your application down, because they're just never checked. They're basically just completely ignored in the production build. Cool. As your application grows and it is running in a user's browser, your components will go through this life cycle where they get created, they might get destroyed, they might get updated. The next slide is not one for you to understand right now. I put it in there as reference because I refer to it a lot, so please don't expect to kind of understand this. It's a bit overwhelming. This is a flowchart of the kind of life cycle of a React component, all the methods that might get called, at what points they get called. I've included a link to it in these slides because it's really, really useful, and I refer to it a lot. So I'd highly recommend grabbing that if you do end up building any React applications. All the methods you have are documented here, but you can basically hook into any time a component is re-rendered, any time it's initially rendered, any time it's going to be destroyed and taken out of the DOM if you need to unbind event listeners or do some clearing up before a component is completely wiped. There's a ton of them. They're really useful. This link documents them all. These are particularly useful if, say, you have a component that's going to call out some API to render data. You need to know when the user is about, or rather, you need to know when that component is about to be put onto the page, so you can kick off the API call. The most useful lifecycle hook for this is called component will mount. So this is called just before React is about to render your component to the screen. It's a great time to kick off any HTTP request or whatever you need. So to give you an example of this, I'm going to create a component called GitHub person, which represents a person's data from the GitHub API. I used this in my workshop and we got banned from the GitHub API, but we should be okay. So first I define my initial state, and I'm going to say that I will eventually have this data key. For now, it's just going to be an empty object. You might also choose to have a key called loading, which you set to true, and then you toggle it to false when the request is completed, and you might show a spinner based on that, for example. But I'm going to kind of keep this one fairly small. Then I have this component will mount a hook, which React will call for me at the right time. I call this getData function. This is just using the fetch API. It's in the JSPM, but I left it out of the slides. Basically, it's triggering an HTTP request to GitHub to grab the user's data and returns a promise that will resolve when we have data back. So then once I have data, I'm going to call this .setState and give it the data from GitHub back to me. And then my render function, I'm just going to render this .state.data.name and this .state.data.company. So when I first render this, you might get a glimpse of from, as in the paragraph, completely empty. As I said, you could keep track of if the HTTP request is loading or not and show like a loading screen or whatever you'd like to do. But once this data comes in, we do get Jack Franklin from Pusher out the end of it. Again, there's a link there, you can go and have a look yourself. So that's kind of all the code I want to show you. There's also this really good blog post called Thinking in React, which gives you an idea of how if you've got this big application, you should start approaching the idea of breaking it down into a bunch of smaller pieces or React components. So I highly recommend giving that a read as well. I think it might use the mailbox example, that might be where I got it from, can't quite remember. But it's a good way of kind of showing like the mock-up of what you want your app to look like and saying, well, these will be the components and splitting it down and so on. And really in these 30 odd minutes, there's so much more I haven't touched that I just want to touch upon very, very briefly. The first is that the React is just the view layer, right? It's not a full kind of monolith, not necessarily in a negative sense, like Angular or Ember, for example. So one of the things you don't get is URL support. For this, the kind of go-to solution is a thing called React Router. I'm not going to go into any code, I just want to make you aware of it. If you do want to build a slightly bigger React application and you need to use URLs, as you should do for any kind of application really, and you don't want to, we've all sent an application to someone, like a link, and then it's not been on the same page because they use JavaScript and they don't update the URLs. React Router is a really nice way to have that built into your React app with pretty minimal effort on your behalf. Additionally, if you would like data management, once you get past a kind of reasonable size, you're probably going to want some more structure to your application state. For this, one of the more popular implementations is called Redux. Its idea is basically, as we have this JavaScript these JavaScript single-page applications that become more and more complicated, your code has to manage more state. If you think of a big app, you've got like the user and then all their friends and all the messages and so on and so forth. What Redux does is it adds in this idea of a store that has all your data in it, and the store passes properties down to components, and then when a user does something that might cause some data to change, like a button click, those components can communicate back up to the store saying, hey, some data's changed, you need to do something. The key thing here is this isn't like an Angular data binding, things aren't being constantly kept in sync, it's all going in one direction. The components tell the store something changed, the store passes that new stuff down to the components which React then re-renders for you. I could do like a whole talk on Redux, luckily for you I'm not going to, but it's really nice if you do get to a point where you'd like some more kind of structure to your data. And there's so many things I could have also talked on. I know we've got React Native covered this evening, but things like universal React, so running React on the server as well as the client, and all the benefits that comes. I did a talk on that at FluentConf, I've written a blog post on it. I've got an example repo on GitHub, which you can hunt down. I'll tweet out some links after this, or maybe add them to the slides where I put them on the slide deck. React is really easy to test, particularly because the way its render function is pure, and it's just very, very straightforward to test React. They ship a React test utils library, which makes it even easier. Again, I did a talk on that last week at React Amsterdam that should be online soon. I've got a blog post on that, which I might add to the slides where I put them online. React Native is after me, so I'll shut up. And then there's a bunch of cool stuff around React and CSS as well, and how we make these two play nicely. And do we just write CSS and JavaScript because JavaScript is the future, or do we stick to traditional CSS? There's a whole bunch of interesting work around that as well. And just to end, one of the things I really, really love about React, which I think is slightly underappreciated, is how much you just get to write plain old JavaScript. React gives you these components that gives you nothing else. And coming from a world where I worked with Angular and I had to wrap things in Angular services or Angular factories and Angular modules and all that stuff, which isn't necessarily bad. When I work with React, I really enjoy that if I need to pull some code out into a standalone object, I can just pull it out into a standalone JavaScript object. I don't have to work with its module system or its system of doing services or whatever. So I think if you've used an Angular or an Ember or whatever it might be, I think generally they're really good frameworks. But you find yourself a bit frustrated with some of the kind of boilerplate that Angular or Ember might make you write. You might be pleasantly surprised coming into it from React. So I'd really recommend when you're working with React as well, bearing in mind that most of it, what you're writing, should be plain JavaScript. And your components should stay pretty small, and all your logic can exist outside of your components as JavaScript functions. So that's all I've really got. React, that's the homepage of React. If you Google React, you're going to get to the right place. If anyone has come from London or wants to go to London, on the 10th of June, I'm doing a whole day workshop on this stuff. I got told earlier that I haven't sold a single ticket, so it'd be really cool if you could come, please. Maybe I've sold one since the other day when I got emailed, but yeah. Else it's going to be me talking to myself for 8 hours, and I can't do that again. So my name's Jack, that's me on Twitter, that's my email, that's my blog. If you've got any questions after tonight, then please feel free to just ping me on any one of the number of networks I'm on. I'm around for the rest of the evening, obviously for the next talk and for pizza and for going to the Apple, which is the only reason I come to Bristol. But yeah, I'm also happy to take questions now. As I said, I'll put the slides on Speaker Deck. I'll go through and add a few links to some other blog posts on some of that extra stuff I touched on at the end. But yeah, any questions, and thank you very much for listening.